I'm really excited to introduce Scott Freeman today. So Scott is from the University of Washington. He's a principal lecturer there, and from the biology department at UW. And I'm really excited because I TA'd for him when I was an undergrad there, and I have really great memories. So Scott received a UW Distinguished Teaching Award. He is the author of the biological science textbook, I think now in its 5th edition, and the textbook Evolutionary Biology. Him and the team at UW have really done some really great work in kind of revealing the impact of active learning on students, or active kind of teaching techniques on student learning. And he's going to tell you all about that. So what I want to share is this really great memory I have from when I TA'd his course. And we were in one of the biggest kind of lecture halls at UW. And you can imagine that there's like 500, 600 students in there. And I just remember him turning it to the students to do some kind of activity in that lecture hall, and just the sound of the students all chatting and working on that together, that's what I kind of remember. And that's, if I had to put a sound to what active learning is, that's kind of the sound I always think of. And so here's Scott. So we're excited to hear from you.
Thank you, Eunice. All right, so we're going to get started here with your first question of the day. Who is this man? It is Konrad Lorenz, winner of the Nobel Prize in Physiology and Medicine for his work on animal behavior. Who are these birds?
His children.
They're gray-leg geese, yes. What are they doing? Yeah, they're actually imprinted on his boots, but they're following him around because they're imprinted on his boots. What is this phenomenon of imprinting, considered one of the sort of least complex or forms of learning possible, more primitive types of learning? What does it have to do with the question on this slide? Any of you know what the average wait time of a college professor when he or she asks a question of your class and you get silence like that? Give me a guess. Yeah, 1.5. Yeah.
We're still lecturing because it's the way we're talking to us. Yeah.
Exactly. I work in a big group office, and this beautiful human being, he's an MD from Harvard and used to run the endocrine residency program at my medical school, but he loves to teach undergraduates, so he would teach regularly in our intro series. Did a beautiful job, but I made a crack about how ineffective lecturing was one time when he was in earshot, and he came up and he said, well, it worked for me. And so as evidence-based people, we think that is evidence. The sample size is like a little small. It's probably not a random sample of our student populations, but that is why we are still lecturing, because we're imprinted. It worked for us. And so that it's actually, philosophically, apparently that's called personal empiricism, making decisions about your life based on your own experience. All right, so read through these quotes. This is from I heard in a faculty meeting from a person who has an endowed chair. This person is one of the stellar researchers in my biochemistry department on my campus. These are from the literature. I'll call out Harvey Lodish, one of the great molecular biologists of his generation, wrote that in a peer-reviewed article. What do you notice about these statements?
We all say
Believe.
Yeah, they're faith-based statements. This is my favorite. No data, but we're going to go ahead and say a bunch of stuff anyway. And this is crazy. We're evidence-based people. This is what we do all day. This is our role in life, is to collect evidence about how the natural world works. But the minute we start talking about teaching, we sort of throw away all of our training and start making stuff up. And I pound this drum because we have a huge cultural problem in our country of making decisions without evidence, of making stuff up. And that's why we have this. If I were giving this talk in Oklahoma, I'd show MSNBC and I'd get a bigger laugh. But all right, I'm going to go through some data on student performance, focusing initially on introductory biology at the University of Washington. So this is our local story that Eunice mentioned. She was this is a data point here and help teach this course. So when you do this work, you have to control for the student. If you're going to do experiments in classrooms and have some defensible outcomes, you have to control for the student, the instructor, and the test, the assessment. We're going to control for the instructor. I'm going to show you 6 quarters of data where I'm the sole instructor of record, starting in 2002. And we're going to focus on failure rates, initially at least. And the reason, well, we'll get to the reason a little bit later, but I want to talk about the importance of this because I have, well, here's a quote. This is from a guy who, let's see, I'll keep him de-identified. He's won a Distinguished Teaching Award on my campus. So the highest honor the university gives for teaching excellence in undergraduates. And he said in a faculty meeting, "I can't worry about my struggling students," this is a direct quote, "they take so much of my time." All right, so I'm saying we're going to concentrate on failure rates. He's saying, no, our job is not to worry about the struggling students at all. So to unpack those 2 perspectives, look at this graph, and it's complex, so I'll walk you through it. We have a regression model that based on academic history, specifically college GPA at the time of starting the course, and SAT verbal scores, we can predict that R-squareds are about 60%. We can explain about 60% of the variation in how students actually do in introductory biology based on those 2 variables. All right, that's the predicted grade, where students are as the outcome of that model. All right, so we've been the students. These are students who are predicted to fail, not go on in biology. At the time this was made, you had to have a 1.7 to go on. Now we're at 2.0. These are students who are getting C's, and these are students who are excelling, getting A's and high B's. All right, now EOP on the y-axis stands for Educational Opportunity Program. EOP, Educational. So those are students identified by my admissions office as being officially, the official quote is educationally or economically disadvantaged. So there's certain high schools in Washington State that just trigger EOP, that the preparation is so poor, or low socioeconomic status students are going to be in EOP. 75% of our underrepresented minority students. So can anybody tick off what are the ethnic groups considered underrepresented by NSF? So when people talk about URMs or Latino, Latina, African American, Native American, and then like you guys, we have a significant percentage of Pacific Islanders and Native Hawaiians. All right, so those 75% of the EOP students are also URM, but we're focusing on, so this is basically a low socioeconomic status, underprepared signature. Again, we're not saying that, that's the admissions office. All right, so this is the percentage of students in that total class, as Eunice said, often 500 students or 700 in the class, who are EOP, based on these bins of predicted grade. This is the actual percentage. We had about 15, 16% this quarter when we made this graph. So you tell me, we published this in Science. Tell me, what would you title this figure? So take a second, talk to each other, and then tell me what you would title it. I'll tell you, I'm from the upper Midwest, so I can say this. I grew up in Wisconsin, went to school in Minnesota. When I give talks in the upper Midwest, I have to, like, if I ask people to talk to each other, boom, dead silence. Like, no, you guys, just talk about the graph and figure out what you're going to do. Pooh, dead silence. So who came up with something? If this was my class, I'd have a randomized class list, and I'd call you guys up. Go ahead.
40% of EOP students are predicted to fail.
Yeah, 40% are predicted to fail. Or 40% of students with no credit out of the course are EOP, even though actually only 15% are.
So EOP students are overrepresented in the failure category.
Yes, another way. Yes, as a friend of mine, when she first.
Wrong, because they don't total to 1. So it's something that.
No, in this bin of students who are predicted to get no credit, 40% are EOP. So a friend of mine looked at this and she said, oh, okay, disadvantaged students are disadvantaged. And this is now, when my colleague says, they take so much of my time, when you look at the data, now it's clicking for him that they are students of color and students from low, and he doesn't like that coming out of his mouth. So I've seen this graph, understanding who the struggling students are, turn people around on a dime and start talking about how do we redesign our courses to help these students who are flunking out of STEM and basically getting denied STEM-based high-paying careers. So that's why I focus on struggling students. All right, I started out by lecturing because that's how I learned. And I did very well under that system. And when I started lecturing in introductory biology, here are the failure rates. So this was, again, you needed a C minus D plus to go on. And this is no drops. If you included drops, these are over, this is pushing 20%, this is well over 20%. You had to have a 2.5 to be able to major in biology. So pushing, with the drops, pushing half the class was in danger of not being able to major. And these were sophomores. We had a Gen Chem requirement, so they'd been in college a year. And then they got to intro bio. And at this time, I was doing what I called modified Socratic teaching. How would you characterize that? Yeah, what I'm doing right now, asking questions to the class. So the students like that. I'm not just talking straight for 50 minutes. I would ask them questions. I was learning a lot of student names. I would counsel, advise struggling students after the first exam, hold a lot of office hours. So I was getting high evaluations. My chair was just delighted. He said, oh my gosh, these are stellar. And I was in the bathroom throwing up because the students were just getting killed. All right, so then I started reading in the literature on what was going on in research on education, and we started doing experiments. We compared back-to-back sections with using cards or clickers. Can anybody describe what those approaches are? What are cards? Anybody use them here?
It's peer instruction. We vote by showing you a card.
Yeah, you can just, so it's a simple technology. If you ask a multiple choice question, you give the students color cards, or just A, B, C, D, or 1, 2, 3, 4, and they hold them up. And then how about clickers? Do you guys use those here? Yeah, we call clickers the gateway drug for active learning. And they're being widely abused, but that's another talk. Okay, and then, so those are multiple choice questions. We give short answer exams. University of Washington, I've been claiming we give the largest, in terms of number of students, the largest short answer exams in the history of higher education. UBC is right behind us, but we have about 20% more students than they do. They also give short answer exams in intro bio. And Eunice can tell you she's graded them. I've graded them, yeah. So anyway, we wanted, and about 30% of my students are speaking English as a foreign language. So we're giving them practice with high-level multiple choice questions, but the students also needed practice with writing short answer exams that were coherent under time pressure. So that's what the practice exams were all about. And when we instituted this, we replicated it over 2 quarters. Again, when I was the instructor of record, we got the first significant drop in the failure rate in the history of the course. All right, so I kept reading and kept thinking and was talking to people and giving talks and stealing ideas from people. So now I go to what I call a lecture-free environment. I don't lecture at all. Now my ideal PowerPoint stacks have no declarative sentences, all questions. And so the students are always, I'm still talking about 40% of the time, but it's to introduce the next problem, give the background on how the experiment's set up or what the hypothesis is coming from, and then a set of questions for the students to work on. And then either they have a clicker question or they have a worksheet they have to fill out and hand in for participation, or I call them at random. With 500 or 700 students in the course, they are on task. They don't want to have their name called and not feel prepared. So that's the lecture-free environment that Eunice was talking about that she TA'd. And we've had the failure rates drop down to pushing 5%. When these data were published and I started giving talks, I used to close by saying, if we ever get this below 10%, I can die. I'll die happy. So now I'm ready to go. So I made this up. I call this low structure. This is me doing most of the work. The students are sitting there mostly, maybe taking notes. A friend of mine in physics education says the person who's working the hardest in the room is the one learning the most. So that was me. And then the students are getting some practice with clickers. Now I'm beating their brains out. I get this steady stream of data, reading quizzes every morning at 6 a.m. I look them up. Great, they've got all the basic vocab. We're going to work on problems in class. And they're in class just working, as Eunice was saying, the place is loud during that 50 minutes. With feedback from me, the TAs are walking around helping students with the problems. And that's what we call high structure. The students have got this structure to learn how to think like a biologist. And so we've been focusing on failure rates. I show my students these data the first day of class, and I also show them this one. The percentage of A's has now pushing 25%. That's 3.5 and above. I showed these data. Bill Gates Sr. is one of our regents, and he came to a talk about these data, and he was getting hard of hearing, and so he talks really loud. And so he raised his hand. I said, yes. And he said, Isn't that just great inflation? I sort of went. And fortunately, Eunice was part of the team that analyzed data on the exams. We did 2 separate analyses on every exam question the students had taken in those 3 quarters. And we had 3 raters. Did you do the Blooms or the difficulty?
I did the blue.
Okay, so 3 raters looked at them and rated them. Where are they on Bloom's taxonomy of learning? Is this an analysis problem? Is this a memorization problem? Whatever. And so we quantified where they were in terms of cognitive challenge. Sorry, we don't have time to show the data, but and then we also did a difficulty. So I showed those data in that, and bless his heart, Bill Gates Sr. said, oh, great. Most people look at the data and have said, if anything, the course has gotten harder, like much harder. Yes?
So could you comment on attendance? Did attendance go up as well?
When we did that cards and clickers comparison, we showed cards are awesome because they cost 2 cents. You bring in an index card and you can get students working on questions. Clickers are a lot more overhead. But we showed overall no difference in exam scores. Yeah, but attendance was very different. And sorry, we're going to work on a meta-analysis, so I don't have time for a lot of these slides. In clickers, it started at 92, 93% and stayed that way, flat line. Everybody's in class, over 90% every day of the quarter, because they have course points at stake. In cards, back-to-back sections, it went like this, down to about 70%. In May, it got nice. It was spring quarter. It went down to 33% one day when the sun came out. So overall, no difference. But when we looked at the bottom quartile of students, only in cards versus clickers, we were at 0.07. P is 0.07 that the bottom quartile, more students passed. And I actually counted. It was 15 students. But we couldn't publish it because Ari Fisher said 0.05 is significant. But those 15 students are significant to me. So, and everybody else who teaches in our course. So we use clickers. So yeah, huge attendance difference. That was a long answer to a short question, sorry. Okay, now about the achievement gap. So everybody is doing better. That is critical. I had a conversation with Cliff Poudry, formerly of NIH and now of HHMI this morning. He said, what about the top achieving students, Scott? Those are the guys who we're going to hire. And I said, they're doing better too, Cliff. It's okay. And this line is in here because there are programs like the Meyerhoff Scholars at University of Baltimore, Maryland, University of Maryland, Baltimore County, or the Berkeley Scholars up at UC Berkeley, where if you invest a lot in capable students coming out of really single-parent homes or crummy high schools, and you support them with supplementary instruction and undergraduate research opportunities early in their career, and subsidize their tuition so they don't have to work for pay outside of class, they'll perform beautifully, but they're massively expensive. Right? If you come in and spend the money that their moms and dads didn't have because they're not investment bankers, then yeah, the students do well. The nice thing here, the thing that's going on here is that we're spending less money. That 2009 data I showed you, that was after the budget crisis. We lost 50% of our state funding in 2 years. So the lab hours got cut, TAs got cut, we had fewer instructors per student. And this is what our achievement gaps looked like historically. So we're not spending more money, we're spending less money per student, and see if we can do anything about the achievement gap. This is where we started. So these are all the major gateway courses in general chemistry, CS, calculus, calculus-based physics, and Psych 101 for the STEM courses on my campus. So again, here are EOP versus non-EOP students, and you can see they're just, our median GPAs in these intro courses in STEM are typically 2.6, 2.7. So what are the EOP students getting based on these gaps? If overall the average grade is a 2.6. Yeah, 2.1, 2.0, 1.9, if that's an overall average, right? The EOP students would be pulling it down. So then you say, well, who's going to grad school? Who's going to professional school? Or who's even getting the major in STEM? So these gaps are large. And then when we looked at data, my gap, these are my 6 quarters that you just looked at. I was actually just killing the students because I was giving high-level exams, a lot of analysis, all data-based, design experiment to show that type questions. And I wasn't preparing the students, I was lecturing at them and then expecting them to magically figure it out on their own without any practice. So my my gaps were at 0.8, and then when we went to high structure and I was actually giving the students the practice they needed to be successful, that gap is cut in about half. So we published that paper in Science in 2011. So any questions about sort of the local examples, what we did with our course series at the University of Washington? We teach our whole year-long sequence now in this style. Go ahead.
So do you have sections outside of lecture where they're also doing problem solving?
No. The class meets 4 times a week and they have a 2-hour lab. Used to be a 3-hour lab. After budget cuts, it's 2 hours a week. TAs have to they teach the lab, they grade exams, and they attend class to help with exercises during class. Go ahead.
Was there any flipped course content that they would have to prepare ahead of time?
Yes. Well, yes, but although now flipping has been around forever. It's a great. The term flip was created by 2 chemistry teachers in Colorado, and it's a great meme. Everybody remembers flipping. Now people associate it strictly with videos, but the general idea is that students, when they come into UCSD, they are, you guys have experienced, I don't need to tell you, they're ferocious memorizers. They're brilliant memorizers. What they're terrible at is putting any ideas together into something we think of as a scientifically sophisticated analysis. That's what they need us for. So the idea with flipping is offload the information, what they're already good at, onto them. So videos are one way. We use reading quizzes. It's just, and online quizzes on the basic terms. So they come in with we're not laying that cognitive load of laying a bunch of terms on them. They have it, and they can start to work problems. So yes, that high structure is all based on the flipping concept. Yep, exactly. That's really integral. And the other thing is, you see, because a common issue in active learning is, well, you're spending all these times on problems, it's labor intensive, it takes time. What about the content? Biology is very, in my intro book, I actually counted one time, students, if we expected students to learn every boldface term, not all the other terms, just the boldface terms, they'd have to learn 17.3 new words every class period. So that's a lot of content. But if I ask 10 or 12 questions every night before on terms, and I do that 35 times, they have a lot of content. I just make them use it. Okay, any other questions about the UW data? All right, so now the issue is think globally. What about STEM in general? What about the rest of the world? So I'm going to walk you through a meta-analysis that was published about 13 months ago in PNAS. And I started this work January 2nd, 2008, and we published last year. It was over 6 years. And my message to you, never do a meta-analysis. If you want to enjoy your life, it's really a horrible process. Anyway, what we wanted to do was contrast any active learning intervention. Even we'd read some papers and say, oh my God, really? You expected this to help your student? But there it is. It's something other than lecturing versus traditional lecturing. Same class, same institution, 70% of the time with the same instructor. All right, it had to be a course. It couldn't be a Psych 101 experiment, with volunteers. And it had to be a class session or recitation, so not labs, not projects. And in any STEM discipline, this is the largest and most comprehensive meta-analysis ever published on active learning in STEM. And then we were focused on performance. There's tons of data on student affect. Do they like it? Do they become more engaged? Do they identify more as a scientist? We didn't worry about that. It was just how are they doing on exams, or especially in math and engineering, and CS, computer science, where failure rates are just gruesome. The investigators often report Ds, Fs, and withdrawals, DFW, because that's if you're in that bin, you're not going on in the major. So it's a threshold. All right, and then we also had exams. We were strict. They had to be identical. No, we thought they were about the same, or some of our colleagues thought they were equivalent. No, they had to be identical or drawn at random from a common pool of exam questions. All right, so this is the process. This is why you don't want to do this for 6 years and 5 months and 6 days. I know I just start to get flashbacks. All right, the failure rate data. So we had 67 studies that reported a failure rate, out of the same course with this traditional lecturing versus active learning contrast. If you're in the biomedical literature, if you're reporting the intervention at work, the patient lived versus died, you report an odds ratio. And this is, did you flunk, did you not flunk? So that's the standard you report an odds ratio. But the problem is, so 1.94. And you think, great, what does that mean? So you can convert that to a risk ratio, and those data are 1.5, meaning just what you're reading up here, 1.5 times more likely to fail. That number has meant a lot to people. We're hearing that a lot. People quote that back. 1.5 times more likely to fail in the same course, usually with the same instructor, just because you're doing something that's active besides sitting there and listening. That's a lot. And then another way to look at it, if you look at all the average failure rate under the active learning treatment was just shy of 22% versus just shy of 34%. That 12% difference is a 55% increase in failure rate when you're lecturing to students. That's another number that really grabbed people. All right, now I want you to look. I've been yakking too much. These are the disciplines that had DFW data. These are means for that discipline and 95% confidence intervals. Here's the average with those 67 studies in the overall CI. So you tell me, what would you title this figure? These are the, yeah, I mentioned the sample sizes.
Active learning is great in geology.
Yeah, it doesn't work in geology, right? You're overlapping, so that's not statistically significant. No statistical significant difference. What's the sample size in geology? 2 studies. Not surprising. How about in the other STEM disciplines?
Active learning helps everybody.
Yeah, it's happening across STEM. Yep. All right, graphing the same data a different way. So here's the 12% overall difference, and here's the histogram of individual studies, binned, just to be convenient to look at. Here's no difference. What's going on here? Why did we shade those bars black? Yeah, failure rates went up with the active learning treatment. Did you hear that? Somebody said, it's geology. Well, I looked at these data and I went, oh yeah. And then I reminded myself, you can kill yourself with aspirin. I mean, you can do anything badly. And this is an issue now because I'm old enough that I remember in the 90s, if you went to a teaching workshop or seminar like this where people were thinking about how to do more innovative teaching, and you ask somebody, oh yeah, do you do anything cool in your class? People would say, oh yeah, I use technology. Do you remember what that meant? Yeah, use PowerPoint instead of transparencies. So you read PowerPoints instead of reading your transparencies, and that was a big deal. So now you talk to people and say, do you do active learning? And they'll go, oh yeah, I use clickers. We have a mature literature on how to use clickers effectively now, and I'll go into classrooms with people who are just patting themselves on the back about their active learning interventions, and I just start spinning in my chair. Because I think, have you read that paper by such and such? It was published in Science, and you're doing exactly opposite what the data say you should be doing. And have you read this paper? It was published in, yeah, so lots of clicker abuse. All right, same data yet another way. This is called a kernel density plot. It's just a histogram that's smooth. So this is our 12% difference. This is average failure under lecturing versus active learning. So here's that smooth histogram for failure versus for lecturing versus active learning. So what are you guys seeing here? Yeah, you see the overall shift? Less variation, exactly. You're seeing it tuck in, and especially, look at this loss of volume in failure rates. I mean, you look at these in biology, 50, 60, 70, 80% failure rates. There are disciplines, especially in computer science, and some calculus programs, people say, yeah, we flunk 80% of our students. Like that, and so at least these what we call first generation studies, where we're just trying any sort of active learning intervention, seem to be helping with these really, what I consider grotesque failure rates, over 50%. All right, and you can dig into the paper if you want to get all these details and the methods, but don't let people tell you that, oh, active learning is fine, but it doesn't work in large classrooms. We're not seeing that in the DFW data at all, or it's only for intro courses. Not so. My medical school is completely redoing their first 2-year curriculum with intensive active learning from day one in the top-rated medical school in the country. All right, now that's the DFW data. Now the exam performance data. you don't report an odds ratio with continuous data, you report an effect size. So this is the difference in means in the two treatments divided by the pooled standard deviation. So this is in units of standard deviations. So on average, on an identical exam, you go to some sort of active learning, on average, again, student test scores will go up by about half a standard deviation. So again, you think, well, what does that mean to students? So again, geology with 2 studies, computer science with 8, GWIS. We did have 158 studies in this with data that were met all the criteria for the study. So when we looked at a bunch of STEM courses on my campus and looked at, well, if students got 0.47 of a standard deviation higher, what would that mean for their grade? And it comes out to about 0.3. So those medians I was talking about, 2.6, 2.7, now those are 2.9s or 3.0s. Same students, different teaching. Oh yeah, and this is my cue to remember. There were 2 other smaller meta-analyses published over the last 15 years of similar contrast active learning and traditional lecturing in STEM. And their overall effect sizes were 0.5 and 0.52. So it seems to be fairly robust, independent of study and author, that we're getting these kinds of results. And in K-12, that's my reminder, in the K-12 literature, the accepted threshold is if you do an intervention in a grade school, primary, or middle school or high school, and you get an effect size of 0.2, that's considered grounds for policy change. At 0.2, we're at 0.47, 0.5. We're undergraduates like, we're blowing this out of the water. Okay, with class size, again with the exam data, if the authors reported class size, this is just the histogram, the raw histogram, and I just looked at this and said, well, that looks kind of like a little normal peak. Let's call that small, under 60, and here's a little normal peak. Let's call that medium, under 120, and everything else is large. And when you do that and parse out the effect sizes by class size, there is a statistically significant difference. It works better, you get larger effect sizes in smaller classes. But you still get an increase over lecturing in any class size. And again, similar, you can read through other results with majors, non-majors, and intro versus upper division with the exam data. These are different studies than the DFW ones you looked at before. Okay, so the meta-analysis says these 2 punchlines are the ones that people are remembering. And this matters. This is a classic study that was the Sloan Foundation sponsored, published in '97 by Seymour and Hewitt. When the title of the book was talking about leaving, why capable students leave STEM. And one of the reasons is just, I'm not doing very well. I'm getting killed in these sort of cookbook labs and huge enrollment classes where people are lecturing to me. So we could make a difference in the number of STEM graduates coming out of our programs if we change our teaching style. Okay, so this paper came out, the press embargo for PNAS comes off on Monday afternoons, and the Chronicle covered the paper inside Higher Ed. This was the 4th most read paper that Science published last year, this commentary on the PNAS paper. We submitted to Science, and the editor, I know there, Pam Hines, wrote back and said, well, that sounds really interesting, Scott. We aren't going to consider it, but if you publish it somewhere, let me know because we'd like to do a feature on it. It's like, thanks a lot, Pam. All right, so on Tuesday morning, I got this series of emails from my TAs. We were in the middle of class, and the TA said, Scott, the paper, the meta-analysis told us about, it's in Reddit. Go look. And I said, wow, cool. What's Reddit? So we were on the front page. I'm not kidding. I had never heard of Reddit. That's how out of it I am. So we were number 3 for most of the day. David Bowie retired, otherwise we would have been way up there. But we did the Pope had announced he would baptize aliens. Sean Connery had come out about his aborted career at Manchester United, so it did pretty well. I looked the other day, and the abstract for this paper has been downloaded 90,000 times. Took me forever to know. That's a joke. So at least it started conversations. God, people are going to remember. All right, so this is the paper. Now we're getting to what you saw as the printed. This is a project I'm working on right now. Because if everybody's doing better, and we see, if everybody's doing better, we don't do anything about achievement gaps, about the biggest income inequality, social mobility, probably the biggest issue in our culture right now, of what the United States used to stand for, the place where everybody has a chance. And now it's like, well, maybe not. So if everybody's doing better, that's great, but we don't do anything about gaps. You have to do something that's disproportionate for students who are underprepared, who didn't get born into wealthy families. So you saw the data from UW, that's that Hake paper you just walked through. UNC Chapel Hill basically did a parallel independent experiment. Sarah Eddy was our postdoc, and she dug into their data and helped Kelly Hogan publish this paper. She was able to parse, at UNC Chapel Hill, they have a lot more underrepresented minorities than we do. And so they saw that for first in family to go to college, it wiped out Kelly's course changes when she dropped lecturing, wiped out the achievement gap for first in family students and dropped it by, the African American students in her class were 20 points behind on average, the white kids. Now they're 10. And she calls it a medium structure course. She says, I've got a lot more work to do. There's a lot more I can do with my students. So similar in physics, classic studies in calculus. San Francisco State doing biology. This just came out from New Mexico State. Ralph Presler and Beth Schuster are seeing disproportionate benefits for their mostly Latina students. Women in male-dominated courses. So this is where I get to I've got to dig into the literature more and do a really thorough review, if not a meta-analysis, of data sets on parsing out by different student groups. But it looks to me, at least my survey of the literature right now, is this looks pretty robust. And I'll try to formalize it. But at this point, then you just start to wonder, what are the ethical issues? We have a drug that works, and we're not using it? That's a tough one to swallow as a community. All right, latest data set I'm going to tell you about is just in prep right now. Does anybody familiar with the phenomenon called stereotype threat? Can you describe it briefly? Just how would you characterize?
Basically, the worry about reinforcing a particular stereotype due to an action or performance.
Great. Yep. Nicely said. So a stereotype like, any of you old enough to remember the Talking Barbie that came out and had the famous Math is hard! Yeah. I've got to get one so I can use it in these talks. I mean, it's just, you can imagine it created an uproar. It was not that long ago, right? Maybe 15, 20 years? Anyway, so girls can't do math, right? Everybody knows that. That's a stereotype. Say again? They cry in lab. It's terrible. Thank you. I would have forgotten that. Yeah. These things, that didn't happen 20 years ago. That happened 10 days ago. So the idea is when you're in a threatening environment, if your group is stereotyped, and another one is white men can't jump. Somebody did white men are under stereotype threat when it comes to jumping. It's true. There's a dissertation thesis on it. All right, so if you're in an environment where some stigma, some stereotype about your group, whatever it is, in whatever environment gets activated, like a Native American friend of mine says, he's in business, but he says, I give up to give a presentation. The first thing in my head is everybody knows Indians are stupid. It's the first thing he's dealing with, right? And so you ask, is he actually spending all his glutamine and GABA on giving his presentation? No, he's worrying about dealing with what all these white people think about Indians. So you're underperforming because the people without stereotype are just working on the problem, so they're doing better. That is stereotype threat. It causes you to underperform. You do. So if you give a group of women a math test and say, this is going to evaluate how good you are at math. These are really hard problems and are really going to tell us about your ability. And you give the same group of women the same math questions and say, oh, we're just scoping out these questions for possible use in GREs or some tests. We just want some feedback. They will do better on the second condition. That's stereotype that you underperform. So there is there's an intervention that was published in Science in 2006 by Jeff Cohen and colleagues, and then followed on with a paper in 2009 that's based on a 15-minute written exercise where you affirm, this is the actual instrument. The students see, we did it online. Cohen did it originally pencil and paper, but you give the students, we do this on day one of the class, You give them this list of, and this is his work, not mine. You give them this list of values, and then they write a little essay on why these values are important to you. The control condition, we randomize. These are large randomized controls. The students in the control condition get the same list. They pick 2 that are least important to them, but they write about why they might be important to somebody else. So same time on task, same time in the course, same values they're talking about, but not a personal affirmation of why, basically your values and self-worth. All right, we did that in the course that Eunice was telling you about that she TA'd when she was an undergraduate. We replicated it 3 times. So here's the demographic. And we learned to do it twice after some preliminary experiments. We do it, as I mentioned, day 1, and then we learned that it was more effective if we did it a second time, and Cohen has done some iteration experiments. We give the students the exercise again right after they get their second exam back. So it's about week 6 of the quarter. What do your undergraduates look like about week 6 of the quarter? Yeah, you just laugh. They're just beat up. They're just beat up. So that's why we started iterating it. So look at these data. This is our URM students. Again, those four self-declared ethnic categories. These are the white students. We're just comparing URM versus white. And here's the treatment that did affirm their personal values twice in the quarter, each 15 minutes each time. Here's the control treatment. These are standard error bars. So and that's exam points. This is exam points. This is out of an R. These are what we call model-based exam points. So student academic ability and preparation is in these models. So this is control. This is an apples and apples comparison. 2 students of the same capability or academic history who have done the treatment or not done the treatment, white or URM, are being compared here. So another one where I want you to tell me what's the title of this graph.
I'll say, I'm not seeing a whole lot of difference. Overlapping error bars, but maybe I'm reading it wrong.
Yeah, overlapping area bars here. There's no difference between the URMs and whites in the control condition. Yes, treatment eliminates the performance gap. There is a statistically significant difference between these guys and these guys. No difference here. And it's been true in all this literature on stereotype threat affirmation, is that the majority of students, there's no effect whatsoever.
So can you just repeat, because I'm finding this hard to believe. So you gave them.
Everybody found it hard to believe.
A little essay at the beginning of class, and nothing to do with the course material.
Nothing to do with the course
And
material.
then they did it again, and that's it.
That's it. Cohen, when the paper came out in 2006, it caused a mild uproar because people absolutely didn't believe it.
What do you tell them you're doing it for?
Did everybody hear the question? You practice deceit. I have permission from my institutional review board. That's how I spent this morning we're going to do another experiment on women. Women are underperforming in our courses. We just published that. And we think we know why, and we're going to do an intervention to see if we can solve that issue this fall. Anyway, our IRB, we told our human subjects group, we said, if we tell the students why we're doing this, we will activate stereotype threat and actively harm our students. And they said, oh yeah, that's very clear. So we never tell them what they're doing.
So you just give it to them and you just say, I want you to do this?
We don't lie to them. We say this is a national writing exercise that's been shown to help with student performance.
And are they given any feedback, or do they?
No. And great question. Cohen's group, actually, they never even read what the students wrote. We've dug into it a little bit because one study showed that the students in the treatment wrote more about belonging. We're not seeing that in our data set. We think that's more important. That was younger kids that were junior high, and it's like, what were you worried about when you were 14? It was belonging to a group. So we don't know what the students are responding to in a college environment yet. Go ahead.
Did you tell the students that you would not read what they wrote?
No.
Because it seems that what you're doing is showing
Sorry,
how you're
just
for the students.
to clarify, we told the students this is a nationally validated writing exercise. It's used routinely in courses, which is all true, and that they would get course participation points for good faith effort. Those were their instructions, little email. But I'm sorry, I talked over your question, so.
I mean, it seems to be one explanation could be that they feel more involved because they feel that you care, because you're asking them these questions. But if they knew you weren't reading it, that might obviate the advantage.
We haven't done the experiment. The control condition, though, I would claim is controlling for that. Because if we're saying we're doing this writing exercise and it's about values, it should control for that expression that the instructor cares. What Cohen saw in his point, he said it's a little bit like when vaccination first started. People said, what? You're putting in 1,000 copies of this antigen? And we're saving millions of people from smallpox? What? That's crazy. So he uses an immunization analogy to say that the issue is if students affirm their self-worth in this threatening environment where they feel like everybody thinks I'm stupid, if I open my mouth, they're going to say, oh, you're one of those stupid blank kids. That you're saying, I'm okay. By the way, it doesn't help the A students. We didn't break it down, but in most of the published studies, it's like and this works for women taking physics in UC Boulder at calculus-based physics. They do the intervention there to help with the girls who can't do math. There's no effect on the A students. It's like those students have figured it out. Like they don't care what anybody thinks of them. They know they're good. It's the B, C, D students who show the big effect. They're the ones who are not self-confident, not sure I should be here. And the idea is that you affirm your personal values, and then we have them do reading quizzes and talking in class, and they're engaged, and all of a sudden I'm okay. I'm doing fine. I can track this. And then that's Cohen's idea, is that you get into a virtuous cycle of, I'm doing okay here. Maybe I'm not so threatened. This is going to work out. But we'd have to dig in. We'd have to do focus groups. We'd have to do qualitative research. So I'm a quantitative guy. So it's not my... So we need some anthropologists, sociologists, and psychologists to dig into students' heads. Okay. Doesn't work for, no effect on women, Asian American, or international students, white or first generation students. They're now using...
In your class?
In my class, yes, yes. By the way, some of these interventions, not the stereotype threat one, the one we're going to test with women this fall, if you please not talk to anybody in my class. It's called a mindset intervention. It's basically train students to be okay when they're challenged by really stiff academic material. They're using it with every incoming freshman at University of Texas, Austin. And they're showing increases in student. That one takes about 45 minutes. They're saying for African American kids, students, they saw 10% increases in the percentage of students who had 12 credits after their first semester with a 45-minute intervention. And they're doing it at scale. That's 7,000 students who are doing that at UT Austin. They have miserable first to second year retention. They lose about 40% of their students. Okay, so the interventions are fun. So this is what we kind of think is going on. We're doing the analyses right now to see if we can actually produce the data to support this hypothesis. So if we have gaps at the 0.6, 0.8 level under traditional lecturing, when we redesign the courses so that students are practicing instead of sitting there, we can cut it about in half, is what our data are suggesting. And then if we get rid of the what I like to call the racist crap that students have to deal with, then they can perform at par with their peers. That's what we think is going on. Again, we're digging into the data. I was doing emails this morning to see if we can nail that. All right, so again, back to the ethical issue. This quote was a writer named Graham Wood was writing about some of the innovative new models and not MOOCs, some other Minerva and some other initiatives in undergraduate education. And this line, so this was published in The Atlantic a little over a year ago. He called higher education one of the most sclerotic sectors of the economy. And I like to say, I have to explain to my colleagues that wasn't a compliment. And this is, sorry, that wasn't very nice. So this is an illuminated manuscript for the University of Bologna and the University of Paris were the first two Western-style universities about 1,000 years ago. This is from 1350. This gentleman's name apparently is Henry of Germany. What is he doing? Yeah, he's reading out of a book. Now we read PowerPoint slides. The students are following along in their book. Now they follow along with the notes that we've posted on the internet. So is this a sclerotic segment of the economy? The students in the back were talking, or sleeping, or texting. And the pre-meds in the front row are hanging on every word. So no things happen. I was just at graduation Saturday and Friday, and here I'm in these funny robes, right? Like it's 1350. I mean, we are in these really conservative institutions. So yeah, change is hard. And And it's hard for everybody. I mean, it's hard for hospitals to change their practice to cut down on antibiotic resistance, right? To get everybody to wash their hands before they go in a room or dip their feet, whatever it is. So people study change. How do institutions and individuals change? How do people stop smoking? So these are two brothers who are actually business school guys, Chip Heath and Dan Heath, and their popular metaphor is that to make effective change based on the literature, you need three things. And they use this kind of funky analogy, but it's memorable to me, so I'll use it. You need a rider, so the mahout is the rider on the elephant. So those are the data. So let's use the example. My dad smoked all his life. He was a pediatrician. So he had the data, right? So so you need that. The Surgeon General's report in 1964 was a meta-analysis that basically laid it to rest, that it's not about, the data anymore. So the elephant is the emotional element, the ganas or desire to make change. What is the elephant for my dad? Yeah, he was addicted. Yeah, by his own admission, he was fiendishly addicted. So you should be thinking now, what if this is lecturing and active learning, what's the emotional element? And then the path is, how do you get there? So if it's smoking cessation, what's sort of the path? How do you help a friend quit smoking? Create the path so that they can actually get to where they want to go. Nobody smokes in Southern California.
Give them a program, get them involved in the program.
Yeah. There's often social support, or families will get together and say, let's get all the ashtrays out of the house. Nobody smoke in the area. We're not going to restaurants where smoking is allowed. Just help her out. Help him out. Yep. So we need that sort of path. Now our issue is we've got a bunch of guys like me, old white guys, who are the mahout. So we've got data now. That's what we've been working on for 45, 50 minutes here. And this is what I've told you is a small piece of an enormous and growing literature. This is the tough one, right? I have friends, dear friends, who are, I'm a lecturer. I'm paid 100% to teach. I have a friend I'll never forget. I was in a faculty meeting talking about some of these data and what we were doing in the intro course. She was an assistant professor. She was getting her tenure package together. And she's a beautiful human being, has a heart of gold, but her eyes were literally bulging out of her head, and she said, I can see the data, I can't do that. I can't do that. She needed a system that rewarded her and that provided a path.
She needed the mindset integration.
That's what we're going to do this fall with the women in science. So all three elements. It's not enough to know what you should do. You have to have the tools you need. Now there are path elements, like you guys have the seminar series going. You have a Center for Teaching and Learning on campus. I just gave a talk at the Aracta Fellows. Those guys are getting a bunch of training as postdocs where they start out their teaching careers doing innovative stuff. To me, the big thing is the system. We've had reports from NIH, NSF, the National Academy for over 30 years. But we live in a system where your tenure decision, P&T, and indirect costs are coming in because of your grant getting ability. Your prestige, I refer to it as anyone can teach. And it's flippant, but think for a second. If I did a horrible job teaching, I had 1,100 students at last fall. My course probably made the University of Washington close to $2 million in tuition money last fall. What would the ramifications for my chair or dean be or my provost if I did a crummy job with those 1,100 students? Nothing. They pay the same tuition. In fact, if they have to repeat, wow, more tuition. I'm being really flippant, I apologize. But there's no consequence. Anyone can teach. Now, what happens if I'm not successful with my grants? Or getting published? Only certain people get their grants published, get their grants accepted. Only certain people get their papers published. That's where the prestige, our identity, comes from. That's the selection. So to me, what we have to do, we have to create a selection scheme where excellence in teaching is rewarded, where it makes a difference to our institutions. And I think that's got to come from the bottom up. It's got to come from students, and I think particularly from scholarship providers. The Pell Grant, Department of Education came in and said, well, that's nice, you have these learning objectives for your accreditation, but we want to see evidence of student learning before we write checks. Bam! Our provosts and deans would be all over us to improve our student outcomes. Then not anyone can teach. I made a crack I was giving a talk, departmental seminar at University of Indiana about 2 years ago, and I was sort of first getting on this theme then, and I said, my pipe dream is that after a really dismal organic chemistry course, the students are doing flashcards and reaction mechanisms and memorizing structures, that if the provost got 200 emails after that course from those 500 students in the course saying, I want our tuition back, that was miserable, I don't know anything about organic chemistry, I said I thought change would happen. And it turned out the provost at the University of Calgary was in the audience, unbeknownst to me. She made a beeline for me and she said, if that happened, I would make change happen in 36 hours. And she was serious, man, she was lit up. I was So I think it's got to come from below. And with that, I'm going to close and ask if you have any questions. So these agencies have helped us out a ton, including my own institution. And the meta-analysis was unfunded. So we did that with these two molecules. That's caffeine, and this is plastic. So thank you. Let's see a question. Yes?
How do you measure teacher performance?
Great question. Yeah, this is going to be a fun question and answer. You hit on one of the biggest problems in the industry, in my humble opinion, and that is teacher evaluation. I had a long conversation with a woman named Liz Boylan, who's now head of undergraduate programs at the Sloan Foundation. She was a provost for many years at Barnard and at CUNY Queens. She lives and breathes promotion and tenure. To her, that's the number one issue she wants to work on at the Sloan Foundation. Right now, what do you use at UCSD to evaluate teaching? Student evaluations. What are the issues with student evaluations? There's a large literature on student evaluations.
They don't know what they don't know.
Say again?
They don't know.
They're novice learners. We're asking them to do a very sophisticated meta-analysis or metacognitive exercise, evaluate teaching. And so it's unreasonable to expect them to be good at it. And in general, they're not very good at it.
The more they learn, the lower they rate the professor.
Often, right. And related to that, there's a huge grade inflation bias. You give A's out like candy, wow, your evaluations go up. That's not what we want to have happen in STEM.
And the lecture gender bias.
And there's an enormous gender bias. So now I was giving a talk in Ohio, and this came up just a couple weeks ago, and I started to get agitated, and I said, my deans and stuff will say, yes, I know they're flawed, I've read some of the papers, but it's all we have. And I said, I'm at the point of just saying, they are worse than nothing. Oop, I just said it again. So we have a huge issue with evaluation. I think what's going to help us is there are instruments being published now. I wasn't participating in a study, but our research group at Washington just published one this month that objectively quantify classroom behavior. So some are just basically time motion study, like what's the professor doing, what are the students doing. The one that our group just published is actually research-based, and you're trying to capture, like, let's say clickers. Then you're actually quantifying, was it a higher level question that provoked discussion? Everything out of the literature. Do you let students answer by themselves? Is there time for discussion? Is there an instructor debriefing? All these things that we know from experiments promote student learning all get ticked off in this instrument. If we have those kind of objective measures, I think that could help a lot.
And what do you do for faculty who want to improve their teaching? What resources are?
So resources for improving teaching, my advice is always to do what I did, personal empiricism, and that's find a group. Find some people who you like, and you like their energy and their ideas about teaching, and can create some conflict, disagree, and have them visit your class. Nothing I ever do ever works the first time, so I depend on people being there, TAs, to give ideas about why it fell flat on its face. And so find a group. There's Centers for Teaching and Learning.
So there aren't best practices identified yet?
Oh, sure.
Where are
Yeah, they are. There's no. I go to the primary literature and read.
So if it's not mature enough yet to have been reviewed and condensed?
Reviewed and condensed in best practices. No. With some segments like using clickers again because they're so common as a first thing to use. Clickers can be awesome. Don't get me wrong. When they're used correctly, the UC Boulder has a site out of their Science Learning Initiative that Carl Wyman sponsored that basically takes you through the steps to use clickers correctly. We're producing a video that will do the same thing with clickers.
So you spent about 10 seconds on your own teaching, which I found fascinating and would have liked to hear more about, where you said
You guys won't talk to each other. You're hopeless. I can't.
in your PowerPoint slides you have no decorative statements,
Yeah.
just questions,
Yeah.
and then you stand up there.
I've got a copy of my immunology intro in my folder I can give you. Yeah.
Well, anything you have that you think, well, even if it only works for you, I think I'd like to learn more about it.
Yeah, and it's not. My dean said that the other day. He said, "Oh yes, God, nobody could teach the way you do." And I said, "We have postdocs who have never set foot in a classroom who come in and teach the way I do, and I can tick off 6 or 8 people in our group alone that teach in the same style, all evidence-based."
Are they imitating you?
No, I imitate them in a lot of cases. Yeah, like I have a bunch of colleagues who have developed worksheets in class. Like there's a brilliant one where we walk the students through how to do PCR, and they have to. We just give them, okay, here are the DNTPs, here's the polymerase, here's this long stretch of DNA. We don't even tell them that's template, and then we have these little things, and we say, well, we don't even tell them they're primers. And then we say, okay, here's the temperature, what's going to happen, and they have to start to draw what's happening inside their tube and draw the products. So worksheets like that, I steal those from my colleagues.
Yeah. I mean, what's always been true is that really talented teachers are successful, and everybody else not so much. And now, it looks like maybe there's some general things coming out.
Yes.
Non-talented teachers.
Yeah, I agree.
More effective.
Yeah, like anything else, you remember the old line is 2% inspiration, 98% perspiration. So there's an aptitude aspect of teaching, and it would be fun to talk upstairs. What is that? We've tried to mentor people and just given up and just said, he just can't do this. He cannot connect with students. He can't understand what's going on in that novice's head. This is hopeless. But most people have that 2%. They don't have the 98 because of their job description or their history or whatever. So we can work on the 98%. And so there are resources in the primary literature, resources like that string, like there's a case history if you want to use cases. There's a huge database out of the University of Buffalo. You pay $15, I think, and you can use any of them. Simulations from the FET program at Michigan State. So there are a lot of resources. Go ahead.
So it seems a lot of your interventions were things that were uniformly applied to the entire class.
Yes.
Do you have certain flags that come up, maybe even mid-semester performance or things like that, where you label students as more at risk and then provide additional, maybe more personalized content?
I used to do that, and I don't anymore. So everything we've done is for the entire class. I used to early in my career, after the first exam, I'd say, I'm going to be in the study area all day tomorrow, from 7 a.m. until 7 p.m. if you need me. Come in if you want to talk about your study habits. And so that kind of intervention, I tried to collect a little data and couldn't see that I was having any effect whatsoever. So we've abandoned it. So we don't do anything right now for targeted in the sense, in the way you described. Go ahead.
So in talking about what you're doing in the classroom, a lot of variables are being changed at once.
Yes, these are. Yeah, I like to joke. We teach experimental design. I would be dinging myself course points on my exams.
So you're increasing testing, frequency of testing.
Yep.
You're increasing class attendance.
Yep.
You may be increasing the amount of time students spend on the course.
Yep.
You're decreasing lecturing.
Yep.
So, can you parse out which of those is the most important? I guess what
The answer is no.
Is it really that lecturing is so bad, or is it that lecturing in conjunction with these other things would be okay, and that one of them is the most important? Do you see where I'm going?
Yeah.
Which variable?
Yeah, we applied to NSF after this initial. So I knew I was being a horrible experimentalist. I just wanted to do something about those failure rates because I knew the students, and which is just a decision I made professionally. I'll defend it a little bit. There's an experiment kind of going on right now that HHMI is sponsoring. So I mentioned the Meyerhoff scholars at University of Maryland, Baltimore County, with success with African American kids coming out of inner city schools. Yale and UNC Chapel Hill tried similar programs, only they did parts of it. they supplied maybe some supplementary instruction, or they supplied a bridge program for the summer before. They got nothing happening. And so their whole HHMI funding is the whole thing is there's no individual thing. You have to have all these things. It's synergistic. You have to have all the things happening to get the kind of success that Freeman Horowitz has had at Baltimore County. There are some experiments that like only clickers as the intervention. So there are some much better designed experiments in the literature I could point you toward.
Well, I guess, so I'm thinking, really what I'm asking about is lecturing. Is lecturing really that bad? Or is it that if you combine lecturing with a lot of these other things, reduce lecturing, is there any way,
Yeah, thank you. It's very important to recognize there is a place for lecturing. I think it's restricted based on my read of the literature. So lecturing is information transmission. So we have other modalities to do that much more efficiently now through reading or internet or videos or whatever, where we're not taking class time. But still, students, if you know Bloom's taxonomy of learning, where you start out at understanding the basic concept and then or vocabulary, and then you go up to analysis, and the higher levels thinking skills we want scientists to do when they walk into our labs to help us with our research. That's all the higher level stuff we want to have. But it's hierarchical. You can't think about something unless you know what you're thinking about. So you never eliminate the content stuff. That's always the base, the foundation. But we do that the night before, and then instead of the lecture. But if I'm introducing a new example that's not in the textbook they haven't read about, I'll lecture it so that they understand the experimental design. So yeah, there's a definite place for it. Yeah. These are awesome questions, you guys. You've really been thinking about this stuff.
This course that you're teaching, are you the sole lecturer for this?
Usually we often split it half-half. Our ladder faculty can only teach 5 weeks, or they can't do the rest of their jobs.
Okay, so students don't have a choice. Let's say.
Nope.
Okay.
There's a single section every quarter. Yeah.
Okay, because what I imagine is that, let's say students have, lecturers, instructors they end up getting reputations. So
right.
they would say, okay, I'm going to take this, and it's flipped, so I got to do all
right.
this pre-work, and I do this, and it's straight lecturing.
Right.
And
it's less time.
Buy a sample of students.
Yep, not happening. Our chemistry department does that. They have 2,000 students take Gen Chem in the fall. They have 4 instructors in 4 different sections. So that would be a concern. In fact, they're going to get started with some experiments, and that'll be one of our concerns, exactly what you identified. Yep.
So I think we'll head up to the round table upstairs in 4 to 11. So if you want to join us, you can have it with us. Thank you, Scott.
And thank you.